What if the chocolate bar in your hand started its life hanging from a tree? What if every snap, melt, and burst of flavor was shaped months, or even years, before it reached a factory? Most people see chocolate as a simple treat, but behind that smooth square lies a global journey powered by farmers, microbes, machines, and precision science. Why do some bars melt perfectly while others don't? And what really happens inside a modern chocolate factory? From tropical cocoa farms to high-tech production lines, this is the step-by-step story of how chocolate is truly made. Subscribe to Agriline Factory for more fascinating factory tours and behind-the-scenes looks at how everyday products are made. Cocoa farming and harvesting. What if I told you the chocolate you love starts as a bitter, slimy bean inside a colorful pod hanging from a tropical tree? Chocolate begins on tropical cocoa farms, where cocoa trees grow best in warm, humid climates under partial shade. Farmers monitor the trees through the year, pruning branches, managing weeds, and protecting pods from pests and disease. When pods reach full ripeness, workers harvest them by hand using clean knives or hooked tools, cutting carefully so the tree can keep producing. The pods are collected and opened soon after harvest, because delays can reduce quality. Inside each pod are cocoa beans coated in a sweet, sticky pulp. Workers scoop out this bean and pulp mass, remove damaged pieces, and group beans by day or area to keep lots consistent. At this stage, the beans still taste bitter and raw, not like chocolate, but they contain the ingredients needed for future flavor. Quick handling and clean tools matter because early contamination or rough treatment can affect the entire batch. Fermentation. Did you know chocolate doesn't actually taste like chocolate until it starts to rot? On purpose? After harvesting, cocoa beans must be fermented, a key step where real chocolate flavor begins. Farmers place the wet beans and pulp into wooden boxes, baskets, or covered heaps, allowing natural yeasts and bacteria to break down the sugars in the pulp. This creates heat and triggers chemical changes inside the beans that reduce harsh bitterness and build flavor precursors. Over several days, the beans are turned to add oxygen and keep fermentation even. When fermentation is complete, the beans are spread out to dry, usually on raised beds or patios, and regularly raked so moisture escapes uniformly. Drying lowers the moisture level so beans won't mold during storage and transport. It also locks in the results of fermentation, preserving aroma and quality. If drying is too fast, flavor can be trapped underdeveloped. If too slow, spoilage risk increases. Good farms balance sunlight, airflow, and time to produce stable, clean beans ready for export. Transport to factory. Once dried, beans are sorted again to remove debris, flat beans, and obvious defects, then packed into breathable sacks for shipping. They travel through exporters, ports, and cargo containers before reaching the chocolate factory. At intake, factories treat cocoa like a high-value raw ingredient that must be verified before production. Quality teams take representative samples from each batch and check moisture content, bean size, odor, and defect rate. Many facilities also run food safety testing and confirm traceability paperwork, because cocoa supply chains are global and must meet strict standards. Factories often blend beans from different farms or regions to create a consistent flavor profile. Since natural cocoa varies by season and origin, only approved lots move forward. Any batch showing unusual odors, excess moisture, or contamination risks may be rejected or reworked. This step is where modern chocolate production begins to control variability, ensuring the final bar tastes the same across millions of units. Cleaning and roasting. Before roasting, cocoa beans are cleaned using screens, airflow, magnets, and gravity separators to remove stones, dust, and metal fragments. Clean beans then enter roasting, one of the most influential steps for flavor. Factories roast based on specific profiles that match the bean type and desired taste, adjusting temperature and time to develop aroma, deepen color, and reduce remaining moisture. Roasting also makes shells brittle, preparing beans for separation. After roasting, cracking machines break beans into mixed pieces of shell and nib. Winnowing systems use air currents to lift away the lighter shells while the heavier nibs fall through. The goal is a clean stream of nibs because shells can add bitterness and gritty texture. Modern plants continuously sample the nib stream to confirm low shell content. From here, nibs are the heart of chocolate making, Everything that follows is about turning these nibs into smooth liquid chocolate, then into stable glossy bars. Grinding and recipe mixing. Cocoa nibs are ground until their natural cocoa butter melts from friction and pressure, forming a thick liquid called cocoa liquor, or cocoa mass. This liquor is pure cocoa, both cocoa solids and cocoa butter, and it becomes the base for most chocolate products. Some of the liquor may be pressed in hydraulic presses to separate cocoa butter from cocoa solids. The cocoa butter is valuable for improving melt and texture, while the remaining press cake can be milled into cocoa powder. To make chocolate bars, factories blend cocoa liquor with measured ingredients: sugar for sweetness, cocoa butter for smooth flow, and sometimes milk powder for milk chocolate. Small additions like lecithin can improve viscosity, and a touch of vanilla may round out flavor. At this stage, the mixture still feels rough because the particles are too large. Getting from gritty paste to silky chocolate requires refining and careful flavor development. Exact weighing and controlled mixing are essential, so each batch matches the target taste and mouthfeel. Final transformation. Refining reduces the chocolate particle size so it feels smooth on the tongue instead of sandy. Roller refiners or similar systems crush the mixture into tiny, uniform particles, shaping the final texture. Next comes conching, where chocolate is mixed and aerated under controlled heat to improve flavor, reduce unwanted acidity, and coat particles more completely with cocoa butter for better flow. After conching, tempering carefully heats and cools chocolate to form the right cocoa butter crystals, creating a glossy finish, firm snap, and resistance to fat bloom. Tempered chocolate is poured into molds, sometimes layered with fillings, then vibrated to remove bubbles. Cooling tunnels set the bars evenly, and the bars release cleanly from molds. Finally, bars are inspected for weight and appearance, wrapped to protect freshness, coated for traceability, packed into cartons, and shipped. Through these steps, farm-grown cocoa becomes a consistent, shelf-ready chocolate bar, designed to look, taste, and melt the same every time. From tropical cocoa farms to precision-controlled factory lines, chocolate is far more than a simple sweet treat. Every stage, harvesting, fermentation, drying, roasting, grinding, refining, and tempering, plays a critical role in shaping flavor, texture, and quality. Behind each smooth, glossy bar is a carefully managed process built on agriculture, science, and engineering, working together in perfect balance. The next time you hear that satisfying snap or taste that rich melt, you'll know the incredible journey behind it. Thanks for watching. If you enjoyed this factory tour, don't forget to like, share, and subscribe to Agriline Factory for more fascinating behind-the-scenes food stories.